Good morning, friends. I would like to talk on a chapter in operating system which is called as deadlock. So, what is deadlock? In operating system, processes request for the resources. If the resources are free, that will be allocated to the process. Suppose you have a process P1 which is been asking for a resource R1, and you have one more process P2 where resource R2 is being given to process P2. So what is the scenario here? Process P1 has to wait till the R2 is being released from the process P2. So if P2 does not release the resource R2, then that scenario will go to a deadlock. That is called as a deadlock with respect to operating system concept. If I take an example of a real-time example, which is a bridge crossing like this, you have a bridge over here. The vehicles which is been coming from both the opposite directions will come towards this bridge. As the bridge is so small over here, neither of the vehicle can cross over one another because both are in a deadlock condition. Example, one more we can take it as you have a railway track. Two trains are moving towards in the railway track in opposite direction and come to a point where none of the trains move towards further, and that condition is called as a deadlock. Similarly, that same thing happens with respect to operating system concept. So, there are certain necessary conditions for deadlock to occur. So, the four necessary conditions for deadlock to occur are mutual exclusion, hold and wait, no preemption, and circular wait. If all the four conditions occur simultaneously, then I call that to be a deadlock. If any one of the scenario does not occur, I can make or I can avoid somehow the deadlock from occurring. So what is mutual exclusion is, a process has to request a resource one at a time. Only one process can enter into a critical section for the process of execution, and the other has to wait till this gets out of the scenario. Hold and wait is one process will hold for a resource and another has to wait till that is been released. No preemption is a resource is been given to some of the process that will not be preempted to give it to some other process irrespective of the priority. Circular wait is each one of the process is using the resource R1 and is requesting for the neighboring resource, which is called as a circular wait. If a process is requesting for a resource R, that is called as a request edge. If a resource is been assigned to a process, that is called as an assignment edge. So this is how the graphical representation that takes place with respect to a process. This circle is called as a process. This is called as a resource. This all four box called as a four instances of resources. There are four types of resource that is been taken care. There are four processes can make use of these resources. That is what is the meaning. This is how the graphical allocation of a graph looks for the process and the resources. P1 is requesting for resource R1, whereas R1 is been assigned to P2. P2 is requesting for R3, R3 is assigned to P3. So similarly, R2 is a resource which is being assigned to P1 and one is being assigned to P2. So this is the resource allocation graph. So there are different methods of handling the deadlock. So the methods are deadlock prevention, deadlock avoidance, and deadlock detection and recovery. So deadlock prevention is we have to prevent the deadlock from occurring. So how do I prevent the deadlock from occurring? Is there are four necessary conditions for deadlock to occur. Either one of the resources, if either one of the condition is being violated, then I can make that deadlock will not be occurred. So by violating either one of the statement, I can make the deadlock to be prevented. So in the next class, we'll focus more on deadlock avoidance, which is Banker's algorithm is being used to avoid the deadlock, and the last concept is deadlock detection and the recovery. Once it is been occurred, how do you detect the deadlock and how do you recover that? Thank you.